Ralph back there, if you want to talk about layers and the evilness contained within them, I'm sure we have some conversations.
Yeah.
But there's fair points here. But one real big gotcha is, of course, at the top of your packages, you're going to be probably doing like that apt-get upgrade, update, install Apache or whatever, Nginx. Sorry, I'm not cool. I use Apache, but Nginx. Let's go with Nginx. I'm cool now. And all that stuff at the top of your file, and then maybe a critical security vulnerability came out for Nginx, like OpenSSL, one of the dependencies, right? That line, so you didn't fiddle with that line, you didn't touch it, it'll reuse that cache. So there is a, in the build, you can say disable cache, I think. I forget the command line option.
No cache.
No cache? Yeah. So you can pass it a no cache to invalidate the cache. And there's some other strategies I'm working on. I'm starting to experiment with, I have a file with the version number that I'm using, so I'm versioning my containers. And so it's the first line in my container, I add that file to the container. So whenever I bump up the version of my package, I just change that file, and then that, boom, invalidates the cache on downward and forces a rebuild. So that's how I'm probably going to manage it in the long term, but you can manage it by hand with, no cache in the middle, and you can actually reuse the tags. So like that tagging, chapter 4, 5.7, you can move that to another image. So you can apt-get upgrade and then still have that 5.7, which can confuse you. So that container ID is really the thing that pays. That's the thing that actually refers to something. Or the image ID. God, I'm screwing that up a lot tonight. Okay, so we're starting to come into the home stretch, and this is where we start getting kind of higher order automation. We start building whole systems, whole services that might be dependent themselves on a bunch of components. A database server and, say, a web server. So we're going to talk a little bit about we're going to start talking about some networking. So how to get containers to work together and talk to each other. So that we can now have containers that are operating in a quiet environment where just this service is being dealt with, where the database and the application are interacting with each other. These things are not exposed to the network. There's no need to. The service is the end product of these two things. And then we'll expose that interface out to the network. So we're going to talk a little bit about the networking, about DNS, so that in one container you know how to connect to the other container, how to refer to it. And then we're going to install a Ruby app, a container, fire it up, play with it, and then we'll get to a do it in one line type example. And so let's dig into this. So let's go back to our classic Docker run. And I am going to create a container named thing1. I'm going to run it in detached mode. I'm going to use Debian Jesse. And I'm going to sleep for 1,000 seconds. Oh, crap. I made a typo. -- name. Okay, so I've got a container. I'm going to run that same command. I'm going to change it to thing2. So now we've got a couple containers, thing1 and thing2, right? Been up for a little while. So the first thing, let's go ahead and ping thing1. Okay. So it's not hooked up to my network, and we can see there are no ports exposed. So how do I get to this thing? How do I get them to each other? How do I refer to them? And what you'll see is there's no actual IP addresses for these that are exposed in this context. So you actually have to get in the container to ping thing1. But what we can do is there is the inspect command. Thing1 I'm going to pipe it to less. And remember how I said when you run a container, there's a whole bunch of state, of meta information, and read-write layer. Well, the inspect shows you kind of that state and meta information. And so you can see the state of it, and you can see some configuration, and there's lots of things in here. And we're just going to kind of jump down to the network settings. And you'll see that when this container was run, it was stuck on this network called bridge. For anybody who doesn't know JSON, sorry. And there's a bunch of little options, and so the container is given this gateway, the container has this IP address, and this MAC address, because what the container actually gets is a simulated network interface, a software-defined network interface. So let's go ahead and I did this, so I have this IP address, right? This is the IP address of my thing1 container. When I expected thing1, if I do docker exec thing1 and do an IP addr, am I writing that right? Yep. You can see there's that IP address, right? So that's the IP address of thing1. But what I want is thing1 and thing2 to talk to each other. So I can do a docker exec thing2 and ping that address 172.17.0.4, and nothing happens. You can't ping it. They're not actually able to refer to each other, not able to talk to each other, because I haven't told Docker to allow them to talk to each other. So let's go ahead and let's see. Count thing1. So let's go ahead and just try to ping thing1. Oh, sorry. Count one thing1. And it says unknown host. So thing2 doesn't really know what's going on with thing1. So how do we get these things talking to each other? Well, you remember how we had Docker volume, or volumes. We have Docker network. And this allows us to abstract networking for our containers. Again, this is plug-inable, so you can have overlay networks, which are networks that span multiple machines, but all feel tight and local and isolated. So with the right drivers and so forth, I'm just going to create a network locally on my machine for these things to talk to each other. So they can talk to each other all they want, but then the wide world isn't exposed to them. So that way they have a rich interfaces between each other, but I don't have to worry about the footprint that exposes the network that might be attacked or or might be interfered with. Maybe I'm running 3 applications that use MySQL, and port 3306 is exposed on all my MySQL servers, but applications are connected to an isolated network where their MySQL server is, so we don't have any conflicts. These MySQLs can all run next to each other, don't even know that the others exist. So Docker network ls, and we can see that Docker actually automatically starts up with some networks. Bridge network, which is kind of an isolated switch you might think of on the local machine. A host network, which it essentially says when you run your Docker container on your host network, that container is hooked up to the same network as your laptop. It's not network isolated in any significant way. So if you want fully to expose something, then you can do that. So what we're going to do is we're going to create a new network. So Docker network create. This looks a lot like volume create, and we're going to call it ThingNet. So I created ThingNet, and I'm going to create some more things. So let's go back up here. I did this Docker run thing2. I'm going to create a thing3. Use that same command, but for net, I'm going to pass in ThingNet. So when this container is started, I'm going to connect it to ThingNet. And ThingNet is like a virtual switch. So as I plug my containers into ThingNet, they will be able to talk to each other the same way computers plugged into the same switch can talk to each other. So let's see. Yep, run the same command, and I'm going to create another container, thing4. So now I have 2 containers on ThingNet, and now let's go ahead and go back to our Docker exec, except in thing3, I'm going to ping thing4 this time. And what you can see is I get a ping. So first off, they're on the same switch so they can talk to each other. But the cool thing is that the names are exposed. So the containers can refer to each other by each other's names. So now this makes it a bit easier because now you can hard code in your configuration file DB server. And just as long as you put a container named DB server on the same switch as your other container, that host name resolution will work and your application can find its database server. So this makes it easy to kind of orchestrate and connect things. There's some issues with how I'm doing this. Yes, you're wondering if I run 2 of these in the same, yeah, don't worry, we'll get to that. There are better ways to deal with that, but we can already do this once and it works pretty well. If I go to thing3, or thing4, I can ping thing3, yep. So we've got now networking. So now our things can talk to each other. So now we can start building services where we have multiple things working together, talking to each other, and then exposing what we want them to expose to the network. So let's go ahead and create a service. So am I in chapter 4 or 5? I need to go up to chapter 5. 5, yep. So let's go into this directory called app. And you can start following along right now if you want, because I typed out the code. I'm not going to make you write out a Docker file. I've already written these, but what we're going to do is we're going to run through them real quick, and then we're going to bring up a service. So let's look at this Docker file. So I snagged a to-do application off the internet. You might have seen in your build. I do not take credit. I did not write this application. I think some folks at AWS wrote it as an example. But what I'm using now is this Docker file, and this Docker file does a few things. So I actually I stole this from there's a Rails Docker file, but I wanted something a little simpler to show you guys. So I actually used, this is a Docker image that just has Ruby and some kind of common dependencies installed in it. So from the Ruby image, which by the way is based off the Debbie and Jesse image, so it doesn't take up as much space as you thought. I want to set a meta value, or I guess kind of an attribute of my container, which is that when I run commands, they happen in this directory. And then down here, I'm going to add this gem file to that directory. I'm going to copy this gem file lock to that directory. I'm going to run a bundle install, dropping these things. So I just want to run the production requirements. And then I'm going to set an environmental variable for production, copy in a directory. So to-do sample master, you might have noticed up here, it's a directory. So I'm going to copy that whole directory in. I'm going to copy this database.yaml file in, copy an entry point file in, and then I'm going to set, when this image is run, automatically run the entry point.sh command. So there's a whole lot going on here. The first thing you're going to say is, Tim, why did you do this? And then just copy the whole bloody thing in later. Well, it's because when you ran this earlier, I ran the bundle install on your laptop already, and that's cached. So you're welcome. You don't have to wait for that to happen. So that's why. You wouldn't do this normally. Normally, you would just go ahead and take this bundle install and stuff it in after your app. But maybe you have some changing, maybe you do want to do this because you don't touch your dependencies very often. So you don't need to change the gem file, but you're changing your code constantly. So you might want to do some weird nonlinear stuff. create layers so you can reuse that caching. So, go ahead and keep that in mind. So there's a Docker file. So I've already run the top half of this Docker file, and then the bottom half is actually never been run before. So let's go ahead and run this. Let's go do a build. So a Docker build, and give the tag of chap5-app. And I think I need to, and build in the current directory. So you'll see here, as I said, I already primed the cache, so you don't have to run the bundle, which is good. And then you see it does some work. So it starts creating some new layers for us, and it finally creates a image. So if we do Docker images, we can see we have this chapter 4 app. So what I've done is I bundled a Ruby app into a container that had Ruby installed, and I installed the dependencies. Admittedly, waving my hands about, I did install them while you were watching. And I added some files. So the database.yaml file, I went ahead and added that in, so it's pre-configured for my database server. And in there, I have a database called rdata. Does that seem familiar to anyone? A user called user. Yeah, this is starting to look familiar, isn't it? And I have a server called chapter5db. And if you notice, I haven't created that. There is no chapter5db. So before we can run the service, let's go ahead and create a chapter5db. So Docker run. I'm going to create actually before I do that, Docker network create chap5 net. So I'm going to create a network for this chapter where all the services are going to run. I'm going to do a Docker run -- net chap5 net. So now whatever service I'm about to run, and whatever image I'm going to run rather, is going to run inside the chapter5 network. That container will be in the chapter5 network. I'm going to name chap5db and run it in detached mode. I'm going to steal for myself. So we created a nice database server in chapter 4 that had all those environmental variables configured, and we built it, and we had a MySQL already running. So I'm going to go ahead and steal that image and just reuse it. So cool. So now I have Docker PS, sorry. We can see that I am running a image called chapter5db. It's based off the chapter 4 MySQL database, and it's been up for 8 seconds. It could expose port 3306, but it isn't. So that port is exposed to the network internally, but it isn't exposed outside of this network that I've set up for this container. So, okay, so now we have our database server running. So let's go back up here, and we have that. Let's just delete this. So we're going to run another container in this same network, except that this time we're going to call it chap5 app. And we're going to expose port 80 to port 3000. So what this means is when I connect to this laptop on port 80, or to this container, this VM terminology, on port 80, it's going to map that to port 3000 inside this container that I'm about to run. And the container is called chap5 app. And I'm going to run in detached mode, and I'm going to run chap5 app, which was that Docker file we just built. So we fire it up. So now let's look at Docker PS. You can see we have an app and a database, and you can see that the app is exposed on the local interface. So IP-ADR show E1. You want to do this, if you want to see the example, So this is the IP address that that Docker machine environment set up. When you fire it up, it actually kind of routes, creates the ability to, outside the VM, talk inside. So I'm actually going to go fire up a web browser on my laptop. I'm going to hit that. And here's my application. Tutorial. Cool. So if I go Docker logs chap 5 app, are there any log lines created for this? No, I guess it's pretty quiet. No? No? Okay, sorry. Doesn't give any good logging. I was hoping it would give some good logging. So, yeah. We now connect to a service. So we've got a database server running, fired up a database server, which we stole shamelessly from ourselves from a chapter ago. Actually, if you guys didn't create your Docker files a chapter ago, you can't steal from yourself. But you can look at my example code. And then we fired up an application server, which I stole shamelessly from GitHub. And then hooked the two up, talked to each other. I stuck in a Docker or a database.yaml file inside the container for my application, and that because this DNS res stuff works, that I hard coded what the database server container would be, the name of that container would be, and inside the other container it was able to hit that and automatically map and connect to it. So that's pretty neat, and just to prove that this is at front end, I did a reload and it reloads the page. And you can see that that to-do is still there. So before we go much farther, docker rm-f, and I'm going to delete all my work. Chap 5 app, chap 5 db. I just don't want those things to get in the way. Okay, so now if I go back here, it's dead. It doesn't work. Okay, so now we've created something interesting. We've actually created a service. You could ship this. It would be a little painful. You probably want to write a shell script to fire all this stuff up, create the network, stick this container in there, or stick this image in and run it as this container, stick that container in. A lot of work. And then, I haven't even gotten into taking the MySQL data, storing it in external disk so that, that data persists against containers. I'm not going to show that example here. Actually, maybe I will. I don't know if it's in my next section. But you start to write these things out, and you get them into your Docker files and your script files, and then you don't have to deal with them again. So it's a little hassle, but once you've kind of refined it down, initially you should hopefully have repeatability because you've written this out and you have it automatically generating these things. And so what chapter 6 is that. This is, I'm not going to really get into a huge amount of detail in this. This is more, I'm going to tease you a little bit. So I'm going to show you, I'd be happy to explain a little bit of it, but this is using a lot of parts all at once. And what I want to kind of give you the sense for is that nirvana of, it just works. Okay, so now I know what to build towards. Because often we struggle and we don't realize that the things that are annoying us are actually problems, and that there are solutions to those problems that already exist. So I'm hoping I'll give you a sense of the solutions. I'm not going to get into super depth because this has been a long talk. But then you'll kind of like, oh, I know where to scratch once I start having these problems. I know where to dig. So what I'm going to introduce you to something is something else I quietly installed on your computer, which is Docker Compose. So Docker Compose is, we have all of these containers, and they need to kind of work together and share some resources, maybe have some volumes, and maybe need to be restarted and have environmental variables. There's a lot of little things to get these things to work together. What Compose says is, whereas Dockerfile is all about creating an image, Compose is about orchestrating a bunch of images to run as containers to work together to provide a service. So that's what Compose does. The whole last chapter where I fired up these things and got them to talk to each other, Compose just automates that away. And Compose is where I spend as much of my life as humanly possible because it's really nice. It's also fiendishly featureful and sometimes feature lacking, which is to say, you don't have that exact feature you need, but oh boy, you got a bunch of others that really make life a lot easier. So there's a lot to do, and as I mentioned before, there's this Docker run reference. If you go to Docker Compose, Compose file reference, there's a lot of options here. So I'm only going to show you a little bit. So let's look at Docker Compose. Actually, before we do that, let's cat our environment. So this is one way. You were asking about secret management, and I said, "Oh, were you? It was sorry. Somebody over there was asking." And so this is how I do it, which is I put my secret on the machine that it belongs to. And this isn't perfect for all environments, but the idea is I go visit the machine and I bless you to be production. I bless you to be staging. And then whenever I run my containers on that machine, it pulls that in. I have a get ignore so it doesn't write over this file or anything like that. And it goes ahead and it says, okay, fire up this container and import all of these environmental variables into the container. And then boom, the container sort of configures itself to what the local environment is. And so what I have here is a environment.txt file. And I've set the root password. I've set the database name to TodoDB, to-do user, to-do secret. The host for the database server is chapter 6-db. And by the way, is it host name? I think it's MySQL host name will conflict with something that's in the MySQL container that's not documented, so be careful here. And then I have an environment production. I don't actually use this for much, but you could imagine having if production behave differently. Turn off debug, for example. So I have this file that describes all my environmental variables, and you're like, okay, Tim, that's cool, but how do I use that? And this is where the cool stuff happens. So let's just look at this file. It's called dockercompose.yaml. And so what this file is it's the orchestration of my service. So what I say here, and this is a version 2 compose file. This is a very recent thing. When I wrote this example 3 weeks ago, this wasn't out. So you're seeing things really fresh. I went back and I reworked my examples to be current because frankly this sucks way less hard. This is way better than what was there before. And what was there before was pretty good, so I'm pretty happy at this point. There are a couple bugs I've run into, but anyhow. So this is a YAML file. Thank God it's not JSON, so you can put comments in here like this. So I have 3 basic stanzas, well actually 4. I say there's a version 2 file, that way the Docker Compose command knows how to parse it. And then I'm saying, here are the services, or the containers, that this thing is going to be composed of. And I'm going to have a chapter 6 app, and when I make this chapter 6 app, I'm going to build using the contents of the app directory. And when that app runs, I want to give that container a host name of app. And I want to pull in the environmental variables from environment.txt. I want to do a port mapping. So I want to port, remember that -p syntax, if I don't give it an IP address, it'll map it all. Right? It'll say all interfaces on the local machine, map that. So all interfaces on the local machine on port 80 will map into 3000. We just saw that a second ago. If this crashes, restart it. Hook this up to a network called Chap5. Actually, I should have probably created a new network called Chap6. Lazy, sorry. And then now, so that's how I define my app server. So note that this has 2 points it runs at. So this defines the environment the app can be built in. So I'm pulling in environmental variables using the envi file during build time. And then it pulls that in again during runtime. So this file kind of guides your application all the way through. It's very nice. If you're doing something like this, MySQL 571, that I didn't build that image, did I? No, I pulled that. So what I'm doing now, I'm cheating. I'm just saying, hey, I know what environmental variables you need to fire up. I'll just let you do that. So one of these is something I'm building. The other one is just an image. I'm just using the compiled product and then just tweaking it a little bit at runtime. I'm not even creating a new image. I'm just passing a lot of -e, 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 -e over and over and over. And so now I don't even have to have that intermediate Docker file for my database container. This just makes it a little easier, a little faster. And actually, yep, in my example, you see I have a volume, and I'm saying take the MySQL directory, the varlib MySQL data directory, and stick it in a data volume called MySQL. And you'll see down here where I define my volumes, I have a volume named MySQL. If you don't do this, it'll complain and say, you're calling for a volume, but you haven't defined it. And I'm going to say that MySQL volume is using the local drive, right? It's just going to create something in the local system. Same thing with the networking, networks, chap 5, that needs to be defined down here somewhere. So I'm saying chap 5, I'm going to use a bridge network. In other words, that virtual switch where all these things are plugged in, can talk to each other. And that's it. That's my application. So, cross your fingers, demo. Oh, sorry. Let's just look at the app directory. So remember how I said that build from an app? So if you look in app, that actually is just the chapter 5 example pretty much, right? So in chapter 5, I went ahead and assembled an image from all these parts. So I said, what I'm saying in this file is go into this directory and then go ahead and run a Docker build and create an image and call that image chap6 app and then make that available for me to use later as a service. Does that all make sense? You guys follow? So in theory, let's see, let me just put in my notes. Let's make sure I'm not going to show you a bad example. Yeah, no. So I should be able to type docker compose. So this is a command that doesn't get installed by default. It's kind of a pain in the butt to install. And get the autocomplete for this when you do it in the future. But docker compose. So I'm going to do docker compose up. And so the thing is you remember how docker build automatically looks for a Docker file. Docker compose automatically looks for a docker compose.yaml. And I think it also looks for a fig.yaml, which is the old name, but stick to docker compose.yaml. It automatically looks for that. If you don't name it that, maybe you have multiple compose files that are slightly different from each other. You also have inheritance within compose files, so you can actually say file 1 dash file 2 and merge them. So you might have a development environment that has more services than a production environment where your database is on another server, for example. But here I'm just going to implicitly use the docker-compose.yaml file, which if you don't give it a file name, it will do. And I'm going to say bring services up in detached mode. Go. Let's go back over here. Demo gods. Demo gods. No.
You see the board?
Demo gods aren't working with me. Docker PS.
Did you ever see the boards?
Chap 6 app. I did something wrong.
Is it a different IP?
No. Nope, you can see the container crashed and then restarted. So I could go, So one thing you'll notice is that it prepends the directory that you're in when you run compose. You can override that, but just be careful. That's why I have this subdirectory called to do. But let's do docker logs to do chap 6 app.
See the SQL launch wrong, your entry point. I think your entry point might be wrong because you can't IRB.
Okay. Let's go with the app directory. Entry point, okay. So vi entry point. So, okay, here you can see the magic. I'm auto-generating the, oh, no, I don't have my database file. Here. Ha, that might be my problem. So I created a database template. And I guess I never installed it. So you'll see I put in kind of placeholders for the values. And then in my entry point, I use the environmental variables to fill in those placeholders. So, hey, I guess I did a bad job. So, add database.yaml to, I think it's the conf directory. And then conf/database.yaml. I don't know why my.
Will the add command work in here?
Yep.
This
That's
is
the
the
bash.
That's the
entry
bash
point.
Oh, this is. You're right. Sorry, but this this will work. This part.
We're going to have a
Let's just
separate.
know that we've understood what you told us.
Yeah. Here's where I should be copying. Yep. Here I config, not conf. It's in the config directory. You can see it right here. Yeah, you guys are quick studies. So config. Okay, and what I'm going to do is I'm actually going to do compose up, and what it should do, let's see, do update, I think it is, right? Let's just do a build. So fix that image. Okay. Okay, it looks like it's held. And there it goes. So thank you for my typos. And that was minus my bugs. You can see now, for example, I could check that into a Git repo and I can recreate environments. So if I do a docker compose kill, and I'm going to do a docker compose remove. Yep, I'm going to blow away my stuff. And then I do a docker compose up. Give it a second. Yeah, it just takes it a second to load. There. To do fix example in chap 6. And also notice that I think this will leave the data container there. So instead, a second. No, it doesn't leave the data container. So I guess the remove strips the data container there. So that's about it. That's the big example at the end. So you probably have questions.